Hello students, in this video we will look to find out whether a pair of linear equations are consistent or not by solving them in a graphical method. We have so far solved for such equations whether to find out whether they are consistent or not by algebraic method by comparing their coefficients. Now we will plot graph to find out whether we get consistent or inconsistent solutions. Okay, so from here we will also be able to conclude whether the given pair of linear equations give us a unique solution, whether they do not give us any solution, or whether they give us infinitely many solutions. So let's go to the first problem, which states that state whether the following pair of linear equations are consistent or not. Obtain the solution graphically. And the first equation that is given to us is x plus y equal to 5 and 2x plus 2y equal to 10. We only have to plot two points over here, and it said complete the above table, plot at least 2 points for each line using a graph paper. So let's plot those lines first. So we begin with the first equation, x plus y equal to 5. So for this, what we'll do, I'll take x equal to 1 and check. So I'll write down the equation plus x plus y equal to 5. In place of x, I'll substitute it with 1 plus y equal to 5. 1 when I take it on the other side becomes negative. So 5 minus 1 gives us 4. So when x is equal to 1, y is equal to 4. Similarly, we'll take x equal to 2 and we'll write down the equation x plus y equal to 5. So when x is equal to 2, so we'll substitute in place of x we put 2 plus y equal to 5. So when we take 2 on the other side, it becomes negative. 5 minus 2 is 3. So when x is equal to 2, y is equal to 3. So we've got these points. Now we'll move to the next equation, that is 2x plus 2y equal to 10. Once again, in place of x, we'll take a value. So we'll take x equal to 1 and we'll see what do we get. We'll put down the equation 2x plus 2y equal to 10. Now in place of x, we'll substitute it with the value 1 plus 2y equal to 10. 2 into 1 is 2 plus 2y equal to 10. So 2 when we take on the other side becomes negative. 10 minus 2 gives us 8. 2y equal to 8. 2 ones are 2, 2 fours are 8. That means we get y is equal to 4. So when x is equal to 1, we get y equal to 4. Similarly, we'll take x equal to 2 and we'll see what do we get. So 2x plus 2y, I'm repeating the equation, and in place of x I'll substitute it with 2 plus 2y equal to 10. 2 2s are 4 plus 2y equal to 10. 4 when I take on the other side becomes negative. 10 minus 4 is 6. 2 ones are 2, 2 3s are 6, y is equal to 3. So when x is equal to 2, we get y is equal to 3. If you compare the two, we have taken the same points for x 1 and 2, and here also 1 and 2, and we are getting the same values 4 and 3 and 4 and 3. So which means that these points coincide with each other. Okay, that implies clearly that this pair of linear equations gives us infinitely many solutions. That means that this type of a pair of linear equations, given pair of linear, are not only consistent but they are also dependent. Okay, this is just by having a glance at the points that we have got, we can conclude, but we have been asked to obtain the solution graphically. So we will plot these points on the graph. So I've already drawn the outline of a graph. We have the y-axis, we have the x-axis, and I've plotted and I've put down or designated the units. 1 centimeter is equal to 1 unit on y-axis and x-axis as indicated by the scale. Okay, so now we'll plot the points. So these are the points. Okay, so for x plus y equal to 5, we have got when x is equal to 1, y is equal to 4. So when x is equal to 1, y is equal to 4 over here, and the same holds true for this equation as well. And when x is equal to 2, y is equal to 3 here, and again the same thing applies for this equation as well. So let's plot this, because we are asked to plot just 2 points. Draw a big line this way. Okay, and we can write the equation of both the line. We can write both the equations on the same line because they give us the same points. X plus y equal to 5 and 2x plus 2y equal to 10. If you want, you can try it out with different points. I went with the same points where I took x equal to 1 and x equal to 2 for both the equations. If you want, you can try it with a different set of points, but they will all fall on this line, indicating that the equation that you get are consistent and dependent with each other, also implying that the given pair of linear equations are infinitely giving you infinitely many solutions. Okay, so we'll make a note of that. So we'll make a note here and say, thus the graph of the given pair of linear equations is coincident. This implies that the given pair of linear equations has infinitely many solutions, that is, it is consistent and dependent. So this question was an example of a pair of linear equations which were not only consistent but also dependent, giving you infinitely many solutions. Continue watching videos on linear equations in two variables to learn more about it. Thank you for watching.